All right, now that we have finished decimals, we've taken our tests, you will probably get your results back by sometime on Friday. I have to grade your work and enter your grades in. Everyone who's taking it online and in class, I have to make sure they have completed it before I give you your score. The next thing we are going into is what? Look at the board on your guided notes. Sean. Good. We're going into fractions. Who likes fractions more than decimal points? Raise your hand. This might be a good thing to hear, but we're only going to be doing multiplying and dividing fractions. Okay? Much easier. Those two operations, in my opinion, are much easier than adding and subtracting. Can someone tell me why? Drew.
Dividing, you keep flip change. You keep your first number, flip the next, and just multiply.
Okay. Why else might multiplying and dividing be a little easier? Nathan.
In multiplying, you don't have to change the bottom number. You just keep it the same to multiply the top.
Good. Adding and subtracting, you have to find that common denominator before you do anything, which can be a bit of a challenge sometimes. Okay, great job. All right, so our goal today is we are going to be able to multiply a whole number by fraction and a fraction by fraction. We are going to also be able to represent fraction multiplication with models. I would say within this, creating the models will be the hardest part. Raise your hand if you've done models with multiplying fractions before. A couple of you. All right. Okay, let's go ahead and we're going to look at, I just want you to follow along up here on the board. It is not on your guided notes. You can model and multiply a fraction and a whole number. To model for 2/5 times 3. Okay, step number 1 is you're going to create three holes, right? So 1 hole, 2 hole, 3 hole. Step number 2 is you're going to break each hole into fifths. So we still have 3 holes here. This is 1/5, 2/5, 3/5, 4/5, 5/5. 5/5 is 1 hole. Step number 3 is we have 1/5. So 1/5 of 3. And then we have 2/5 of 3. How can you solve this? What is your answer going to be of 2/5 times 3 by just looking at this model? What could you do? Noah. It's 6/5. Exactly. We have 1/5, 2/5, 3/5, 4/5, 5/5, 6/5. 6/5. What is 6/5 called? Nathan.
1 and 1/5.
What is 6/5 called? It has a specific name. Ian. An improper fraction. Perfect. Okay, you are correct, Nathan, in changing it to 1 and 1/5. What is 1 and 1/5 called? Jay.
A mixed fraction?
Close. You get the first word right. Nathan?
Mixed number?
A mixed number is what it's called. Okay. So that is how you represent a model for this problem. Questions? Okay. Go ahead and answer question in part 2 on your guided notes there. Read through that question and see if you can answer it. You may talk with your neighbors if you would like. Okay, what is our whole? John? It is 4. So how many whole rectangles am I going to create? 3. 4 more rectangles represent. That represents this right here. Now 2/3. What do we need to do to represent 2/3? Jacob. Cut them into thirds. Perfect. Each hole gets cut into thirds. Then how do we represent 2/3? Nathan.
You basically take out the last row and you put check marks over the first two.
Good. We are going to put, this is 1/3, 2/3 of that hole. 1/3, 2/3 of that hole. 1/3, 2/3. 1/3, 2/3. Now, how do we solve from the answer here? How do we get to the answer from this model? Nathan.
You count all the colored boxes.
Good. We're counting how many colored boxes here. This is 1/3. 1/3. That's 2/3. 3/3. 4/3. 5/3. 6/3. 7/3. 8/3. 8/3. Okay? We don't want to leave our answer as an improper fraction. We want it as a mixed number, or if it's just a fraction, we can keep it as a fraction. But all improper fractions, I'm going to ask that you put them into the mixed number. So Noah, what did you get? 2 and 1/3. Anyone have any idea of how do you change an improper to a mixed number? Sean. Yes. One 6. This is a 3. This doesn't look very good. Okay. Here come hands. Drew. 2 and 2/3. Okay, so this is our answer. Let's check this work here. How do we change this? It's a division problem. Setting it up, it's 8/3. How many times does 3 go into 8? We said 2 times. 2 times 3 is 6. You subtract, you get 2. I said we weren't going to use remainders this year. But with fractions, you can kind of use remainders. Like, how many times does 3 go into 8? Altogether. 2 times. How many do we have left over? David. We have 2 left over. Is that going to be our numerator or denominator? Numerator is the top number. Then our denominator is our divisor. You always go back to check your answer. Go from a mixed number to an improper fraction. It is 3, or your denominator times the whole number plus the numerator. So 3 times 2 is 6, plus 2 is 8. Denominator stays the same. Are we good with that? Okay. That is how you answer the problem using a model. Talk to your neighbor of how you solve this not using a model. So, all right, who has an explanation of how you solve this without using a model? Sean.
You multiply 2/3 times 4 and just multiply the top number, which would be 8.
Okay, what do you multiply by a top number? Again. Good. You can change your whole number into a fraction. You change it to an improper fraction. So we have 2/3 times 4/1. 4/1 is 4 as an improper fraction. Ben. What's that? Okay, go ahead and explain the next step.
Multiply the numerator
Good. Multiply your numerator. So 2 times 4 equals 8.
And you multiply both of your denominators.
Good. Multiply the denominators. 3 times 1 is 3. You get 8/3. Multiplying fractions, you just multiply across. Multiply across. I have an awesome video to show you about multiplying across. Okay? It's not going to show it to you today. It will be later on. Okay? So, that is how you get your fraction. Jay, questions? Maybe at some point we will. Okay? Do we have questions on that? Okay, changing whole numbers, you just put it over 1. No questions? All right, we're going to go ahead and move on. We're going to skip the key concept because that is what we just went over. So go ahead and flip it to the back. You have part 3. Okay, part 3. I want you to go ahead and solve 5 times 3/8. Which answer is it going to go through? Okay, we have 5 times 3/8.
Recircle it or
You're going to put the problem. You're going to put 5 times 3/8 in one of these boxes. Which product does it go into? So I guess we can go over the first one. I want you to. We'll do 5 times 3/8. Now our whole number is the first number. Does anything change? No. So what do we do with 5? Nathan?
We put a 1 under it.
Good. So we change it to 5 over 1 times 3 over 8. We multiply straight across, and we should have 15 over 8. Which one is 15 over 8? It's over here. So up here, I want you to write 5 times 3 over 8. On your guiding notes, you just find the mixed number, which is 1 7/8. Yeah, just put not the answer, your problem under the product. All right, your next one is 6 times 2/5. What'd you get for an answer? Sean? 12/5. 6 over 1 times 2/5. 6 times 2 is 12. 1 times 5 is 5. 5 goes into 12 2 times. Having 2 left over, that's our numerator. Denominator stays the same. All right, 2/5 times 6. What do you got, Jay? Okay, we're solving for our answer. 2/5 times 6. Easton. Jaden. 2 and 2/5. That's exactly right. All right, next one. 4/5 times 9. Noah.
7 1/5.
7 1/5. Good. I'm going to solve this one to show you. 4/5 times 9/1. 4 times 9 is 36. 5 times 1 is 5. 5 goes into 36 7 times. That's 35. Means we have 1 left over. 7 1/5. All right, 4/5 times 9 is the same thing. I don't know why it's on there. Okay, 1/8 times 7. We got Nathan. 7/8. Nice job. 1 times 7 is 7. 1/8 times 1 is 8. 7 times 1/8. Ian, it's 7/8, right? Order does not matter when you multiply, even with fractions. 9 times 4/5. Ben. 7 1/5. Yes, I don't know why there's some duplicates here. Okay, 4/5 times 9, it's already here. What about 3/8? Stay there. No. 3/8 times 5. Sean. 15/8. Nice job. Any questions with that? No? All right. That is part 3. Okay, on your guided notes, you have these 3 drawings. Okay? Go ahead. This is how Math Excel is going to shade them in. So you can go ahead and shade them in just like they are up here on the screen. So on your box of 4, we're highlighting the bottom left. Yes, you see your pen now. Yep. You only need one color. The middle one, make sure you're highlighting the bottom 2 left one. Okay, what I want you to do below is put the problem that aligns with the model. You have 3 options. Just go ahead and write below these what questions are. So you are putting these down below. All right, what do we think for this first one down here? John. Good. 1/2 times 1/2 equals 1/4. I would agree. Now, showing this representation, this is a 1 right here and a 1. 1 times 1 is what? 1 times 1 is 1. This whole thing is 1/4. Okay? Representing this, 1/2 is on this side, the rows. 1/2 is on the column. This is the rows, this is the column. What they did is they shaded in this to represent 1/2. They took this side and represented it and shaded this side 1/2. Notice right here where it's purple, that is where they overlap. There's one box that is overlapped. There are 4 total boxes that gives you 4. You're okay with that? All right. Well, what about the second one? What problem is that representing? Ben. Good. 1/3 times 2/3. What fraction is on top? 2/3? John? 1/3? 2/3. Correct. Okay, they shaded in 2/3. Right? And that means 1/3 is on the side. They shaded in this 1/3. Our answer is 2 ninths. Our 2 comes from this box and this box. Our 9 comes from 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, what about the last one? Obviously, 4/5 times 2/3. What number would go on the top? Which fraction? Awesome. 2/3 is going on the top. Multiplied by 4/5. How do we know that? 2/3 is on the top. We're breaking it into thirds. 1, 2, 3. 2 of them are shaded in. Okay. 4/5. 1, 2, 3, 4, 5 total rows. 4 of them are shaded in. 1, 2, 3, 4. Our answer is 8. 1, 2, 3, 4, 5, 6, 7. 8 is our numerator. Number of boxes that are double shaded. The denominator is 15. We count all of these boxes. That is 15 of them. Question. We do expect you to know how to use these models. Okay? I know some of you can just multiply straight across. All of you can multiply straight across, get your answers, but you have to represent it with model. Okay. Remainder of class. I want you to go ahead and work on part 2. I want you to draw lines that match the equation to the correct product. That should say match the expression to the correct product.